it messes up. Okay. Should be live. What is that? Oh, people can't see it because you're sort of clipped, so I only see half of you. Is that Pluto and Sharon?
This is my Pluto and Sharon plushies.
Oh, that's great. They're a binary planet.
They're a binary planet. They orbit and they're magnetic. Anyway,
Oh,
I thought I would add this to my set design back here.
Oh, that's incredible. I haven't got a full view of you set up right now, but so you if you keep going, a little more. There we go. Perfect.
Okay.
Yeah, now they can
They're
remain
sort of over my shoulder.
Yeah, exactly. Yeah, they'll see you over your shoulder. So
yeah.
Hey everyone, you blew my mind before we got started. What did you call this? Happy Monday?
Happy Monday.
Right.
It's still podcast day, but
happy bonus.
Different one that I'm used to.
Yeah. For people who don't know, Kimberly, of course, her intro on the Weekly Space Hangout is to say Happy Podcast Day, and yet I guess it still is a podcast because I will be releasing this as a podcast.
I will still count this. It's just an extra special podcast day for me.
Yeah.
It's an extra special podcast week. I get 2 days of podcast.
Lucky you.
I feel very lucky.
Well, so for people who don't know, I'm assuming like half the audience, I hope, knows who you are. And for the other half who maybe don't know, who are you?
So my name is Kimberly Cartier.
Dr.
I am Dr. Kimberly Cartier. You know, it's been a year and a half and I still forget to introduce myself that way. Dr. Kimberly Cartier. I am a reporter at an Earth and Space Science magazine called Eos, which is the news branch of the American Geophysical Union. And I've been there for the past year and a half since I earned my PhD in astronomy and astrophysics from the Pennsylvania State University. I'm also a regular weekly panelist on the Weekly Space Hangout.
That's right. And last week we had Dr. Jason Wright on. And
yes.
And Jason was your, how does this work? He was your
he was
mentor?
my PhD advisor.
Right.
So he wasn't technically in charge of me, though he gave me a lot of freedom to explore what I wanted to do because, as you may have guessed from my introduction, is I started in academia as a grad student, got my PhD in astronomy and astrophysics, and then immediately afterwards decided not to continue in academia.
Right.
And so about halfway through my grad program, I said, you know what? I will be completely miserable if I do this as a career for the rest of my life. What the heck do I want to do instead?
That is an interesting kind of existential crisis to come to after.
I call it my quarter life crisis. I was about 25 when that happened.
Yeah.
Yeah.
And I'm just trying to think, right? You had done your bachelor's degree in physics.
In astronomy.
Yep. You did your master's, so that's what, 4 years. You did your master's degree. That's another 2?
2, yeah.
Yeah, so you were 6 years in. You're then working on your PhD. That's another 3 years. Mm-hmm. So we're at 9.
So I was technically a year into my PhD program after I'd already gotten my master's, after I'd already gotten my bachelor's, knowing from, I think, about junior year in high school that astronomy and physics was what I wanted to do. I loved doing it. I was great at it. I wanted to learn everything I could possibly think of having to do with space, though I quickly decided that planets were my favorites of all the things. And then I got more and more into the reality of what it would be like to be a researching scientist, because it's not just about learning new things or writing papers or giving presentations or taking classes. I was starting to get more and more away from those things and more into the daily research grind, which is a lot of detail work, a lot of finicky coding, and programming has never been one of my favorite things. They don't tell you quite how much computer programming is involved in an astronomy degree when you start out as, you know, a young and plucky 18-year-old starting as a freshman in college. And, you know, there was never a point where I thought, you know, I couldn't do this as a career. I've always been, you know, well aware that like I could have, you know, stayed as a researcher. There was nothing keeping me back except for the fact that I knew that if I kept doing it, I would really start to not like science. And I never wanted to reach that point. So I started, you know, I did some really deep soul searching for a summer, trying to figure out like what the heck do I like, what part of this experience have I enjoyed the most so
Right.
far? Because I was still at the point where I loved science, I loved space, I loved exoplanets. Like anything you could tell me about it, I would be fascinated. But what part of it did I really enjoy the most? And the part that I discovered, uh, perhaps not so surprisingly for people who know me, is that I really enjoyed learning about new things and then communicating that
That's
new science to
exactly me
others.
too. Yeah, I know it's funny. My, for people who don't know, I went to university for engineering and got a year into that and had the exact same thing, which was like this was all fascinating as I learned it, but I don't
Mm-hmm.
want to like sit down and recalculate load stresses on bridge support structures for
And
my
I didn't want
whole
to program
life.
Monte Carlo simulations
Yeah,
of exoplanet atmospheres. I wanted to know, what is in that atmosphere? Oh, it's water, it's methane. What can I learn from that? What can the
yeah,
entire scientific endeavor learn from that? And how can I make other people as excited about this as I am?
yeah.
And so I tried just about every form of science communication that I could think of, while also continuing to do exoplanet research for 2.5 years. I started almost immediately on Space Hangouts. I started as an exoplanet blogger for a news site. I did local radio appearances. I did local present like public astronomy appearances. I started writing press releases for free for my astronomy department.
Yep.
And I found that I love writing,
Uh,
and I combined it.
uh, First, hi, Dad. My dad's just posted in the comments. I think it's like
Hi,
one of the first times he's been able to watch live. So everyone say hi to my dad. And
I'm Fraser's dad.
that's awesome. Um, so I mean that process of writing, right?
Mm-hmm.
Of taking a complicated subject and trying to kind of break it down and then translate it into a way that someone can get the gist and understand why this work is important.
Right.
How is that process for you?
The process started out very slowly for me. I will say I've known for a while that I enjoy writing. I've always just sort of done it, personal writing or like short fiction stories that I never really shared with anybody. But I like writing. I like words. I like, the minutia. No, I'm serious. Like I get
Yeah.
really excited
Yeah,
when I
you're
learn
an
a new
Oxford
vocabulary
comma
word,
person,
or
aren't
like
you?
I learn a new way to use a word that I hadn't thought of before. I find that really cool. I'm a little bit of a nerd that way. Um, but going from writing scientific technical papers, like the kind that you would read on archive, the kind that are published in, the astrophysical journal, which are for other academics and usually for other experts in your field. It's very different than the kind of writing, you'd go to Universe Today
Mm-hmm.
or eos.org to read. So which is more aimed at either someone with general scientific knowledge or scientific interest, or just the lay public who doesn't really know or care why science is cool. Um, and so it started out really difficult for me, I will say. I started as an expert exoplanet blogger.
Right.
Um, I will say I didn't always do the best job in some of my earlier works, which you could probably still look up. They're not the best. And then I was very lucky in that my PhD advisor, Dr. Jason Wright, helped me connect with other science communication programs in my at Penn State in grad school. There are a number of sort of disparate classes in different departments, one of which was the Department of Geoscience at Penn State, or Earth and Space Science. I forget the exact name, but they have what a class that really helped me sort of understand some of the technical differences in what you need to look at when you're writing for different audiences. They gave me a lot of
So
reference material and like the actual course structure and the background material I needed to understand some of the differences in the different types of science communication.
so this journey that you've taken, you're not the only person. You're not alone. I mean, I
No.
realized early and tapped out and went into science communication without the formal training, or my training is in computer science and engineering, and while you stuck through it and went all the way through. So there's sort of two questions really. One is, if a person is watching this, listening to this, and they're on that same kind of journey, what recommendation would you make to them if they're starting to feel a little burned out on the minutia of the science work, but they do feel like what got them into it is this love of the discovery and the fascination and explaining it to people? Is there a way that maybe they can learn from your mistakes and chase this stuff sooner, or what would you recommend?
So I would recommend, one, don't panic. It's not the end of the world. If you don't want to get a job in academia after going however many years in academia, don't panic. It'll be okay. That's my first thing.
Yeah.
The second thing I will say is, really give it some thought. Figure out what part of it you really enjoy. I sort of cast a very wide net and tried every little thing possible. I drove myself a little bit crazy for a couple of years doing that, which maybe I could have avoided. But one of the things that I did was I actively went out and I searched for other opportunities while I was still continuing on my academic path. I did a bunch of volunteer and pro bono work in science communication. I rarely got paid for any of that extra
I can
work.
recall a show that had your help on a regular basis.
That's true.
Yeah.
I think, Fraser, I never really thanked you for that, did I?
Wait, no, aren't we supposed to thank you for doing the pro bono work for us?
Yeah, but it really helped me, fine tune a lot of those skills.
Yeah.
So I'm still gonna say thanks for inviting me the first time and giving me a second chance after my really terrible first
how it
appearance.
first was. It Morgan who?
It was Morgan's fault.
Yeah.
Yeah. So Morgan and I, who's also, for people watching, Morgan's also one of the panelists on Weekly Space Hangouts. Morgan and I met when we were both actually writing for the same news website where I first started as an expert, as one of the exoplanet bloggers. And so Morgan reached out to me and said, "Hey, I've never met another grad student who's serious about science communication. We should talk." Yeah. And I was like, "Yes, I've never met anyone else either. I'm so glad I'm not alone." And that's the big thing, is that you're not alone in thinking that maybe academia is not right for you, and it's totally okay. And there are so many opportunities when you're at a university, especially a university that's doing research, to explore the different aspects of the entire scientific endeavor. Because it's not just about what you do in the lab or at or at an observatory or sitting in front of the computer screen. There's everything that happens afterwards. Like, you have to write the paper, you have to review the paper, you have to edit the paper, you have to publish the paper. If you're lucky enough, you get to promote the paper and explain it to the media in a bunch of different ways. And all of those are part of the entire scientific endeavor. Sometimes you're lucky enough to be an advocate for science, going even further and trying to get funding from a university or at the political level. And there's an entire array of careers in that direction too.
Yeah.
And the best thing you can do, I think, is just, reach out to some of the people who have already done this. I will certainly welcome any emails that come my way about going into a career in journalism after academia, or any sort of advice that I can give. Reach out to people, because most of the people that you reach out to will be very happy to help, and very happy to save people some of the heartache that they experienced.
I mean, I hope that in seeing the conversations that we have in on this channel and in other channels, the community is really welcoming and just wants you to succeed. And
it's true.
And all you have to do is reach out and be willing to participate in the community, and you will find a community that just wants to help you as much as it can to help get the word out about the work that you're doing. If you seriously want to do science communication, the need is bottomless.
Yeah, and especially anyone who is a science communicator at any level, 100% recognizes the need for more people from the scientific background who want to make that transition, who want to populate our ranks with knowledgeable science communicators and science advocates who are just trying to communicate the incredible experience of science to everyone else. We need lots of people. So
Yeah, yeah.
pretty
And
much anyone you
we're ready
ask
to
will be
help.
like, yes, please do
Yeah.
come join us. And there are so many great so many like intro level experiences, internships and workshops, and 6-week fellowship programs that you can participate in for little to no cost. Sometimes, at the same time as a grad program, or just after in like the transition, or during a summer where you may not have research funding. There are so many different programs where you can get more of that hands-on experience to try it out on a trial basis to see if it's really what you want.
Yeah, I totally agree. And there are so many places now, right, that you can blog on Medium, you can you can record videos on YouTube, you can record a podcast. Like there's no reason why you can't create a body of work today in the field that you're studying, in a field that fascinates you, and I am an example of a person who can just build this stuff up over time through osmosis, as opposed to necessarily going to go to school for it. Like you can definitely,
Yeah.
even if you don't want to, you've got some other career that you're in, and there's something that that you're fascinated by, just help communicate, help get the word out. And I think
Yeah.
there's a lot to that.
I will say one more thing that was really helpful for me that I want to pass along this tip is that if you're still in grad school and you are getting paid through your research funding or through a TA-ship, a lot of the times that your department will also cover the cost of a class up to a certain number of credits per semester. And that's how I got a lot of my science communication courses and actual like accreditations, was through these sort of already paid for semester credits. So I did an internship in Penn State's Office of Public Information, which was super useful. I took courses in how people learn and how people communicate. I took actual science writing courses, and all of this was already covered by what I was already being paid to do. So if you have the option to do that,
Yeah.
make the most out of the educational experience while you have it, because everything after that will cost lots of money.
Right.
And journalists don't get paid that much.
Yeah, I mean, I know that there's things like astrobites, and there's a lot of organized science communication efforts through academia as well, that if you want to, you can participate in and be a part of. I know there's like astro tweets, they take over.
Astro tweets,
Yeah.
there's astrobites, there's all sorts of other shared Twitter accounts that you can look into. um I think Fraser and you and I were talking about before the show about how oversubscribed university public information offices are.
Yes. Yeah. Yeah.
So I went to Penn State, so a lot of my experience comes from that. When I interned in that office for a semester, I learned that the entirety of Penn State, which is an R1 university, it's one of the largest research universities in the country, they have 4 people writing all of their press releases.
Right.
For all of the research that they do. They're incredibly oversubscribed. So if you just want to get some experience writing, press release style pieces, which can be useful for building up a writing portfolio right out of grad school, say, volunteer. Say, hey, I'm interested in writing. Would you mind if I wrote up some of this research for you? And then you tweak it for your office. Add my byline.
Yes. Yeah.
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 That's how I got some of my first stuff.
And this is the problem, right? It's some really interesting research comes along, and a lot of times it only makes it out into some very technical journal, or it goes to a prepress like Astro PH, and people just don't find out about this really important work. And I find I can take any research paper and I can figure out the nugget of news that is going to be useful to explain to people, that people are going to be like, oh, that's really cool that they figured this thing out. But a lot of times,
to be fair, not every single paper has a negative news, to be fair.
I'd say almost every paper, the ones all about the Monte Carlo simulations of such and such atmosphere in the Lyman Alpha Forest, etc. I think that you can, if you sit down and you grill the researcher, you can get to, because I mean, a lot of times there's a reason why they've done this research. They have a question they're trying to answer. And then either if they do answer that question or find some new little piece of nugget of information, if you can tell the story right, I think you can absolutely explain why it's a fascinating discovery. It's just that whether or not these things reach, like when people see their newspaper and they see the same stories come up again and again and again,
Yeah.
that's because someone at one of these universities, someone in the press office wrote the press release and sent it out, and then it got picked up. And there's
Hmm.
tons and tons of stuff that never gets picked up. That
Exactly.
that I
And
find I'm
you know,
always able to get as many stories as I want.
I don't want to discount the value of most of the research that's going on. Like you said, a lot of the stuff that we hear is the large, big, groundbreaking, paradigm changing. Oh my gosh, we almost found alien life sort of things.
Yeah,
Um,
alien megastructures, that
which
kind of thing.
shh, shh, shh. We don't use the M word, do we?
Well,
No, we
we
don't.
learned we
I could
learned
tell that
last
story if
week.
we
Yeah, I know.
want.
We learned last
I c-
week just how close Jason was to
yeah.
the origin of that idea, and you in close orbit as well. So I
Hmm.
think that's all right.
I
We
can actually
covered
no,
it.
I can tell that story. It involves my first experience with large scale journalism, which is kind of interesting. But anyway, to finish my other thought was we hear a lot in the news about these sort of large groundbreaking discoveries, but that's not what the majority of science is. It's a lot of incremental small steps towards the answer to a bigger problem. And all of that research is super valuable. It just usually takes something like 1,000 words to explain it. And that's not the bandwidth that a lot of news outlets allow. So if you have the room to do it, I say that, you should teach about what science is actually like.
Yeah, yeah.
And it's not always every single paper changes the world.
Jack Martinelli just posted, "Hey Fraser, you're egocentric if you think you alone can get to the kernel of truth." Well, I can't believe you said that. Just to be clear, that there are press releases that come out that everybody reports on, but there are also tons of conferences where people are giving presentations. There are journals where people are posting really interesting research stories. And there are a lot of there's just so many interesting resources. And the problem is that the a lot of the news agencies out there don't have the resources to be able to go and
It's
find these
true.
stories. And so I find I have the most fun digging up a story from, say, some presentation that somebody gave at a conference on I don't know, spacecraft that are going to Mars. And it's really interesting ideas, some really groundbreaking ideas, but just because nobody wrote a press release to go along with the presentation that the researchers gave, uh, it just doesn't get any kind of press. And so I find
Yeah.
that for a lot of these stories, I'm just like we're the only ones reporting on it because nobody else is looking through those same sources. So yeah.
Yeah, and I think one aspect of a scientific research paper that doesn't always get communicated is that it's still incredibly difficult to get one of these papers published. So it's not an automatic process where if you get money to do research and you do the research, it's not automatic that you get a paper out of it,
Hmm.
that some journal will agree to publish the results or the non-results of your project. There is many, many rounds of gatekeeping that happen between the intent to publish and the actual paper that people see. And so to get through all of those gates, there has to be some sort of central idea, some central nugget of information that's important enough for that journal to publish about. And I think, Fraser, that might be what you were getting at before, is that every paper has a central focus, a reason why it was
Hmm.
published.
Yeah.
And that reason was obviously interesting enough for
Yeah.
a panel of scientific peers to say, yeah, that's interesting enough. Other people should know about it too.
Yeah, and just because the public, the press officer didn't happen to have the time on
Yeah.
their schedule, they were working on some other piece of work, and they didn't have get a chance to present this. And then on the flip side, if they do have a lot of time, then they are able to dig in and talk to one of the researchers at the university and say, "Oh, are you working
Hmm.
on anything interesting?" And the scientists will go, "Oh, well, we just figured this out." And the press officer will be like, "That sounds great. I'll write a
That
paper.
sounds awesome. I want to
That
write
sounds
about
great.
it.
I'll write about it."
Yeah.
And sometimes if it's more complicated and technical, they are more hesitant because they can mess it up.
Hmm.
and often do,
And
right?
part of that is also on the scientists to be able to explain to a press officer who likely doesn't have the same scientific background that they do and the same wealth of scientific context that a researcher will have. It's on the scientist a bit to be able to synthesize their work into something that is a message that is valuable to other people.
Yeah.
And that's one of the things I feel is getting better in today's academia. It's not great yet. There are still uh, few and far between are the researchers who are great at communicating why their science is necessary and valuable to a non-expert or to the public.
All
And I
right.
think it's getting better.
Yeah.
I wish it were getting better faster.
All right, I got a great question here that comes from
Awesome.
Cody's lab. I want to publish some papers. How would I go about doing that? I got kicked out of school before getting a bachelor's degree.
So one of the things that you could do is find a scientist who's willing to partner with you on writing a paper. In a lot of academic journals, you need to have a PhD researcher as a co-author on your paper in order to get into a lot of the journals that are more widely seen. It's the same reason why a grad student like myself, like I was, before I got my PhD, I never published a paper on my own because I didn't have the credentials as a scientist to publish in a scientific journal. But I have certainly seen a number of papers, really excellent papers that I've covered as a journalist that were first authored by an amateur astronomer uh, who partnered with a professional astronomer that had a similar interest. So my recommendation to you is to, do some Google searching, find out who in the scientific community is working on a similar project, or maybe even just has a hobby or like a side interest in the
Yeah.
type of work that you're doing, and reach out to them and say, hey, I've been doing this work. Here is a draft of a manuscript of this research that I'm doing. Is this something you're interested in? Can you help me?
There
And
was
I
a
think that's an excellent way to get.
really interesting video that came out from The Verge, I think, this week or last week. Did you see it about this?
I didn't
About
know.
searching for micrometeorites. So this is the exact situation. There is an amateur, an enthusiast who has categorized thousands of micrometeorites, and for a long time there was skepticism that these were actually meteorites, but
Mm-hmm.
he's been able to figure out exactly what pollution looks like and what metal fragments from welding looks like, and is left with these pieces that have been analyzed and demonstrated to actually be micrometeorites from space, and has sort of become a world expert in this thing, and partnered with scientists, done a lot of the heavy lifting to look through the individual little micrometeorites and help figure out how to tell which is which, and be able to partner on those papers. I mean, I think the challenge is to not be a crank, right?
Yeah. So that is one thing that you do have to be aware of, is that sometimes astronomers, particularly in fields that are flush with a lot of amateur astronomers doing similar things, or who are in sort of an esoteric field of astronomy, get a lot of emails from crackpots who don't know what they're doing. I
Yeah,
still get those, and I haven't been in academia for a year and a half.
yeah,
So I
I
mean,
mean, I
approach it in
think
a professional aspect, like you would approach any professional colleague,
yeah, and I think the
and show
problem
that you
is
know what
that
you're doing.
exactly, that there
Hmm.
are now a lot of places that people can go and publish their work. There are journals, but they're more vanity journals. Like they're not,
They're
and
They're predatory
or they're
journals
and
who
they're
just
and
want your money.
absolutely, yeah, there are predatory journals that are willing to publish your work in exchange for money, and it's really hard to be able to route around them. And
Hmm.
so I think, but I mean, that if you are serious and you know what you're doing and your work is good, that's a tough connection to make to a scientist, because I'm sure a lot
Hmm.
of them are very nervous, and have a lot of inquiries, and these things don't pan out.
Yeah, and depending on what exactly the research is that you're doing, there may actually be a support network already in place for something like this. There are organizations of citizen scientists or amateur astronomers who all share, a similar research goal. One that comes to mind is AAVSO, which is what is it? Amateur astronomer or
Variable.
variable star observers,
Yeah.
something like that. I may have messed up that acronym, but AAVSO is just for citizen scientists, but they all have the same goal, and they already have established partnerships with certain research organizations and certain variable star scientists to get a lot of that science published. So there may already be some support structure in place for what you're looking to do, and you may just have to find it.
Yeah. So yeah, someone asks, when can you ask questions? As you saw with Cody's lab, go ahead,
I'll ask all the questions.
ask all the questions. So Steve Marson asks, when James Webb launches, what exoplanet would you like to see it focus on first, and why?
Oy. Oh. Okay, so first off, when James Webb publishes,
When it launches,
that's
yeah.
that's
Not if.
very optimistic of you, but yeah. So when it launches, given the exoplanets we know today, which won't be the same exoplanets we'll know when it launches, I still want it to focus on some of the Kepler systems, which you'd have to go with some of the brighter Kepler systems. But there's one that, in particular, I studied in a lot of detail that I think is completely fascinating, and that's Kepler 296, which is a system that has 2 low mass stars and 5 planets, 3 of which are in the habitable zone.
Wow.
Which I think is a fascinating system. I mean, Kepler, discovered so many exoplanets, and not some of them are very like other exoplanets. Not everyone is unique, and not every system is unique, but I think the systems that have multiple stars and multiple planets, many of which are in the habitable zone or approximately Earth-sized, the dynamics of those systems just boggle the mind sometimes. I think it's so different than what we are used to seeing here in the solar system that you start wondering, how did that system come to be? Can those planets really be habitable? Like, what are the conditions there? And if any of you watched Weekly Space Hangout a couple weeks ago, maybe 2 weeks ago, we spoke with Natalie Hinkle, and she spoke a lot about the difference between what we define as the habitable zone and what is actually hospitable towards life. And those are very different concepts. And systems that have multiple stars and planets that are maybe in the habitable zone challenge many of those assumptions. So I'd like to take a closer look at some of those. Not to say I wouldn't also love to look at TRAPPIST, because there's who knows what the heck's going on with those planets anymore, whether they have atmospheres or water or ice, or I don't even know anymore.
Yeah.
Not to say I wouldn't love those too, but I would love to see some of those more original Kepler systems looked at a lot more closely.
One of the jokes that I see unfolding on Twitter is people noticing that such and such planet observation would be an ideal candidate for James Webb.
I saw that.
Right?
Was it Natalie Batalha posted
That's
about
right.
that on
Yeah,
Twitter?
that's right. Yeah.
And Natalie Batalha was she was the project scientist on Kepler. She's one of the principal scientists on TESS, and she's an exoplanet expert of the highest caliber. And what she posted was, you can't claim that your favorite exoplanet is an excellent target for James Webb Space Telescope unless you've actually modeled it through the James Webb simulators to see if James Webb could actually look at it. And I think that's a totally fair point. Having read a lot of exoplanet papers, everyone is so eager to say, this planet would be great for James Webb. And a lot of planets would be great for James Webb. It's true. James Webb can look at a lot of planets. A wide parameter space of planets, one at a time. Not every planet is going to be super interesting for James Webb to look at. And given that exoplanets is really only about 30% of what James Webb will be looking at, there's only so many that it can do.
Well, what is the sweet spot? Like, what is the ideal kind of planet that James Webb is going to be able to take a look at?
James Webb, as far as exoplanets go, James Webb is designed for Earth-sized, temperate planets around low-mass stars. James Webb has a lot of instruments that look in the infrared, which means that it won't be able to look at a lot of hot planets which will be more in the visible or ultraviolet, or planets that are around sun-like stars or hotter. James Webb really isn't optimized for those kinds of stars. But if you're looking at stars that are, slightly colder or much colder than the sun, who have planets that are, in those habitable zones, so temperate, water-rich conditions, those are the types of planets that James Webb is really going to help with. And if you're, a little bit further out from the star, and you have transits that happen semi-frequently, not every 3 days, but maybe every couple weeks, maybe it'll be able to get some really great atmospheric measurements of those planets, and that's what I'm looking forward to.
Right. But like, I think a lot of people are imagining James Webb goes up and it turns on some Earth-sized world orbiting a sun-like star and reveals.
Be like, whoa, cool aliens.
Yeah, reveals
no.
aliens. Yeah,
That's not what it's gonna do.
Yeah.
That's not the right telescope for that. And keep in mind, like James Webb, it's not a wide net. This isn't the one that's going to discover planets. This is the one that's going to do a laser focus on one planet at a time, or one planetary system at a time. If you want the wide net that's going to discover planets, that's going to be TESS, that may be LSST, that's going to be Cheops, that's going to be Plato. Those are your big wide net planet discoverers to, sweep in 1,000 planets at a time like Kepler did.
Right.
James Webb's going to be your laser focus.
But that'll be the frustration, is that you'll know of all these planets, you'll know their orbit, their mass, that's it. And then you'll know kind of its in the habitable
with
zone.
James Webb, you may also actually get information on the atmospheres. So if a planet is transiting, and you can see it transit, and it has an atmosphere, it means that atmosphere is transiting also. So James Webb will be able to apply a method that's called transmission spectroscopy, which is essentially taking a spectrum of the light from a star when there's no planet in front of it, taking another spectrum of the same star when the planet is in front of it, and then subtracting the second thing from the first thing to get a spectrum of just the planet's atmosphere, to see what the star's light looks like when it's filtered through that atmosphere, when the atmosphere imprints that chemical signature on the star's light. That's going to be that's where James Webb's going to be a powerhouse, because right now we have managed to do that for maybe 6 planets in any great detail. 6, maybe 10 at this point. And that's after hundreds and hundreds of hours of observing time using Hubble, which is the best instrument we have up there right now to do that, or Spitzer. You're talking hundreds of observing hours. That's incredibly expensive in space telescope time. But James Webb is designed to do that. Like right now, we're pushing instruments that were never, ever designed to do exoplanets, because we didn't even know exoplanets existed when these things were designed and built and launched. So we're taking Hubble, we're taking Spitzer, and we're twisting them to do exoplanet science when, they were meant to look at galaxies.
So with James, I mean, is there I'm imagining, like, say you do have like a star like the sun with a Earth-like planet that's passing in front. Is that the wrong wavelengths though? Because I know James Webb is more about the infrared. So is your perfect environment going to be a cooler star, like say a red dwarf star with a planet that's reasonably similar temperature passing in front of it, and the temperatures are more into the infrared?
I mean, your perfect star is going to be that cooler star, that K, or that M star, the red dwarf. That is going to be the perfect star for James Webb. Not saying that it won't be able to look at, a sun-like star at a slightly hotter temperature with a planet in its habitable zone. But those planets are much more rare. We don't know of a lot of them, because planets in habitable zone planets around a sun-like star, they take a year to orbit. So you need 3 years of observation to confirm that planet exists. And the fraction of those planets that transit is much smaller than the fraction of planets that would transit a smaller star. And that's just a function of geometry.
So Rami Imad is asking, with the ground-based telescopes, will they be able to do that more efficiently using adaptive optics? So do you think that, when you look at the budgets, right? The budget for things like, say, the ELT, the extremely large telescope, 39 meters, is merely about $1.5 billion.
Yeah.
Compare,
Compared to James
when we
Webb,
think
which
about
is at
James
what,
Webb.
19 billion
No,
right
no,
now?
it's merely 8.6.
Oh, sorry.
Yeah,
Excuse
yeah,
me.
yeah.
I was 10
So
billion off. I'm thinking about the
right.
end budget.
And so for like the price of James, you could have gotten, say, the overwhelmingly large telescope. You've got the 100-meter telescope.
Yes, the Lunar Baseline Array Telescope.
Right, right.
Um,
So do you think that they've flipped? The tools have flipped now, and these ground, like, obviously with James Webb, you can't get that. There's certain wavelengths you just can't get from the Earth.
That's
But
true. There's a lot of infrared wavelengths you can't get from the Earth. There's a lot of ultraviolet ones you can't get from the Earth. That's because our atmosphere gets in the way. And I know I've been talking a lot about all the space telescopes that are going to be focused on exoplanets because I did a lot of space telescope research myself. But ground-based telescopes, man, those are such incredibly valuable tools that often get overlooked in when we talk about the future of exoplanet science. We talk about James Webb, James Webb, James Webb. Oh my gosh. But ground-based telescopes are really the workhorses that have just been doing continuous, steady work on discovering planets, characterizing them, getting more precise, and just a larger volume of continuous data coverage for more than 2 decades. Um, Ground-based telescopes will never be obsolete when it comes to exoplanets. They'll never not be valuable. I mean, even so, take a look at whatever Astro PH published today. There's going to be some exoplanet paper that uses 20 years of radial velocity data from the HARPS radial velocity spectrograph to get a precise measurement of the mass of this planet. That's 20 years of continuous observations on one planet. That's the type of thing that ground-based observing can do. I mean, it can do a lot more, especially now with some of the newer technologies with adaptive optics, with better multi-object spectrographs, with higher resolution spectrographs, with better coronagraphs from the ground, with things like ALMA, which isn't, it does infrared, it does millimeter submillimeter measurements, and it can measure the fine tiny little gaps in a protoplanetary disk, which are essentially like the baby pictures of exoplanets. We can't do that from space. We can do that from the ground. So I will say it'll never not be valuable to have ground-based observing, and we do need to continue to push the boundaries on those technologies too.
Eric One asks, aren't red dwarf stars rather volatile for habitable planets? This is the sad reality that we're starting to find out more and
the answer is
more
about 50-50. About half of them, yes. The issue with red dwarfs is that they're born, and then they live for like 100 billion years, and they don't ever really change all that much. They look a bit different in maybe their first 100 million years. Then they're pretty steady, and at some point they start to slow down in their life. And so we don't ever really know how old an M dwarf star is. We do know that about 50% of them or so are incredibly active. They have very large flares, and a lot of those flares also come equipped with extreme ultraviolet radiation, and just like bursts of ultraviolet activity that can strip a planet of its atmosphere, its water, and sterilize it of all life. And that is compounded by the fact that the habitable zone of a red dwarf star is so close into the star itself, because that's where, the temperatures are right for liquid water on the surface. That's also where the flares tend to hit. So about, 50% of the M dwarf habitable zone planets that you hear of probably nominally are in the habitable zone, but maybe they're actually not hospitable towards life. And that's one of the things that we need to do a better job of characterizing, is that we didn't know when we started hunting for exoplanets that M dwarfs and K dwarfs would be, prime real estate for planets. We thought these stars are way too small. They don't have a lot of mass themselves. Some of them are barely bigger than Jupiter. They can't possibly have enough mass to support a planetary system. We found out that was wrong. So we just didn't know. And so we don't actually have a lot of measurements of the radiation environments and the flaring and the activity levels of many of the M dwarfs that we know host planets. So that's something we're going to have to keep doing. And it's certainly before we claim that any red dwarf star is has a hospitable environment for life, we do need to make those measurements.
And that's going to shift into this idea of starting to figure out some proper, say, biosignatures, things that will
Yeah.
be the smoking gun. And you were the person who really brought my mind around to this idea that in fact finding a biosignature is going to be a lot tougher than we had been hoping.
Yeah, when we hope, we always hope, that if we look at if we take a spectrum of a planet, that we'll see an obvious marker for something like, say, chlorophyll that, is found in plants, or some type of oxygen or ozone that we know can only be produced through a biogenic process and can't be produced, say from volcanic outgassing or something that must come from life. But the reality is that most compounds that we know of in the universe can come from, if they can come from life, there is also a completely non biogenic way to get the same compound. And so being able to figure out what a planet's natural levels of that particular signature, chemical signature is, and then figuring out if you exceed or are depleted in that resource, that may hint at some sort of other process going on, some non I don't want to say non-natural, but some maybe biogenic or artificial way to get the measurement you're looking at. That's going to be a lot harder to figure out. But that's something we might be able to do if we study other planets in the same system or the stars themselves.
Well, do you think that this is something that they're going to crack now? Like, there are people working on this, and they're proposing different biosignatures, and when you match that up with like the capabilities of the instruments that we have available, and sort of cross-reference and go, could we look for oxygen? Could we look for ozone? Could we look for photosynthesis? Like, at some point, do you feel like someone's going to go, aha, I've got it. We just looked for this. And if we see it, then we know there's life there.
I have the hope that we'll get there one day. I always have in the back of my mind is that when we say that we're searching for life, we're searching for life as we know it.
Mm-hmm.
We have to put some sort of boundary on it, or we won't be able to identify what that life is, or if it actually is life. So if we're looking for life as we know it, I have the hope that eventually we'll get there if we can nail down all those other points. What a planet would look like without life, what the star looks like, what the other chemical properties of this system are, what its atmosphere should look like. If we can nail down all those other points, I feel like we will eventually be able to pinpoint uh, a smoking gun for an individual planet. I don't know that that smoking gun will be the same gun for every single planet that we look at.
Yeah, I mean,
And then there's always that little niggling thing in the back of my mind, like, oh, we're searching for only life as we know it. So
yeah.
maybe there is life, and it is there, and we just don't know how to recognize it.
There's some interesting research that's actually being done by NASA right now. Actually, I have one of the papers up here right now at the Laboratory for Agnostic Biosignatures. And I don't know if you saw this. And
I don't think I have.
Yeah, the gist is exactly that, which is, what would life as we don't know it possibly look like? And so they're examining every kind of molecule that could serve as a baseline for life, every kind of solvent that could serve as a way for life to mix its chemicals up, and other, different kinds of energy that they could rely on. And so you could imagine, and then each one of those then generates all kinds of interesting potential biosignatures, each of which of those could be,
it could have a million different permutations of how it actually looks like when we're this far away. One of the things we didn't mention is non-biotic, or techno signatures, which is something that is gaining more and more ground recently.
Yes.
And I know I nixed the M word, but you did talk to Jason Wright last week.
We talked
who leads a lot of the techno signature efforts, and that's another way. Something that stands out as a clearly non-natural physical signal.
Yeah.
whether it's chemical or technological, something.
Now, well, I mean, this was the joke that Jason made last week, which was like, NASA's, or scientists are all about searching for dumb life. Why don't we search for smart life too? What's so wrong with searching for smart life? So, I
There's
think that's.
nothing wrong with searching for smart life.
But
Uh,
there are some real unambiguous signs when you are searching for technosignatures, for example, like seeing a radio transmission in a certain spectrum tells you there is no natural process that we can imagine that will generate radio emissions at a certain
yeah,
megahertz.
there are radio gaps
Yeah.
where we know that there's no natural process that produces a signal in this particular, band of radio signals. So that's a great place for alien life to transmit. So we know that it's a not natural signal.
Yeah.
Stuff
Yeah.
like that. There's nothing wrong with searching for intelligent life. I think, for two reasons, I think that approach is often looked down upon by other scientists. I do not look down upon that approach. I've done some of that research myself, and I admire Jason and all of his work. Well, one, I think it gets a really bad rap in popular science, and in movies, and the guys and gals looking for aliens are always the one with the crazy hair that everyone thinks is like the crackpot looking at the end of the world and being abducted. Like, it's portrayed really poorly in the
Right.
general public. But at the same time, in a more serious sense, here on Earth, we know that for the majority of time that there was life on Earth, that life was not capable of communicating with the outside. Like, we've only gained interplanetary communication capabilities in the last century. But life has existed on this planet, going back billions of years. So in terms of the percentage of time that there has been life on this planet versus the percentage of time where that life has been able to talk to things outside of the planet, if you're going to look for life, the roll of the dice says you're probably not going to find it in the right stage that it's where it can communicate with you.
Science Side asks, what do you think about life on Europa? And sort of generalize this,
Yeah.
like this idea of these icy worlds as a place for life.
Let's do it. Yeah, I 100% think that we're going to. Okay. Maybe I shouldn't say that as 100%. I have very great confidence that we're going to eventually find some sort of microbial or bacterial life in the subsurface oceans.
100%.
Of
I'm just gonna tweet this out right now.
Write that down. I'm on
Yeah.
record for
Yeah,
that.
all right.
Maybe not exactly on Europa, but there are half a dozen other icy moons in this solar system we know have subsurface oceans. There's Europa, there's Callista, there's Ganymede, there's Titan, there's Enceladus, there's Triton.
Yeah.
There's maybe Pluto.
Maybe Pluto. Yeah.
Maybe Pluto. I think that subsurface ocean life is incredibly likely somewhere in this solar system. Let's go find it.
Yeah.
Let's do it.
Yep.
Totally on board.
Yeah. Yeah. And it's amazing how much the evidence is just building with the discovery of hydrogen gas pouring out of these worlds, that we're finding more and more of these places that seem to have some kind of subsurface ocean. It feels like it's a thing we need to do yesterday. And in fact, somebody asked earlier.
Let's do it yesterday.
Yeah, let's do it yesterday. Someone asked, and I apologize. I remembered I was going to fire this one to you. Was what do you think about going back and studying the moons of Jupiter and the moons of Saturn?
Let's
How high
do it.
in the priority list would you put that when you think about the missions?
So I would put that below a mission to Uranus and Neptune, below a mission to Venus, but not much further down the list than that.
That's funny. So someone asked me this question, and I on the question show last week, someone asked for my top 3, and I'm like, well, Europa, but since we're already going to Europa,
we're already going there.
Yeah,
and
I'm going to count that one out.
And in fact, NASA's budget that just got approved yesterday or something include earmarks funds for Europa Clipper and for a lander that they haven't even approved of yet. They say you'll have this money, but you got to do a lander on Europa.
Yeah. That's
even though
so
you don't
great.
have one planned yet.
Yeah, because that was originally in the works, and then it was thrown out, and now it's
and
potentially
nope,
back.
you got to have this. You want this money? You're gonna land on Europa. That's already up there.
I think I can get you to disagree with yourself, though. Titan. Wouldn't you like to see something explore the atmosphere and maybe the seas of Titan?
I do.
Yeah, Titan, Uranus, Neptune, Venus.
I didn't put them in that order though.
No, that's fine.
I
Yeah,
said Uranus, Neptune, Venus,
yeah,
and then not much further down
yeah.
the other
The
icy
other icy
moons.
moons. Yeah,
I
yeah.
I haven't given much thought to which icy moon I would like to see, or Titan, given that it's not no, it's not really icy.
Yeah.
I haven't given much thought to above or below the top three, um, but somewhere in that mishmash of top 10 are Titan and all of the icy moons.
Jeremy Broham asks, since you're confident with life elsewhere in the solar system, then wouldn't you think there would be evidence of life on Mars?
Probably. I think there probably is, and I would think that we'd probably find it in the next 10 years or so.
Whoa! Again, we just like write this
What? I'm
down.
sorry. Writing down
No.
my predictions. No, I will say this because I know that there are a number of missions that are going to launch in the next 2 to 3 years whose sole mission is to look in these places on Mars that we know have the right conditions for life and have the right chemical food and the energy source and the water. Places that we've marked as highly likely. If there's ever going to be a place on Mars that has life, this is the place that's going to have it. We're sending a bunch of missions already there. I think it's highly likely we're going to find it very soon.
So then it's a race. Do you think that we're going to find evidence of life here in the solar system first, or we're going to find evidence of life using one of our telescopes around some other planetary system?
You're not going to get me to make a firm prediction on this one.
You already predicted life on Europa. Come on, I need you to make a stand.
I didn't put a timeline on that one, though.
True.
I think given that we're actually going to set robot wheels on a lot of places in this solar system where we're pretty sure the conditions are right for life, and we don't yet know how to narrow down an unambiguous biosignature around a distant exoplanet, and we don't yet have the instruments in place to actually measure them, I'm tentatively going to say in the solar system versus outside the solar system.
We should have a bet then, because I am on the exact opposite side of that from you.
I will bet you something incredibly minor.
Yes, of course. Yeah.
One.
Next time we meet, dinner's on
like
the
said,
on the loser.
Yes, exactly right. I will buy you dinner if I'm wrong.
Perfect.
If we find life around TRAPPIST G or Alpha Cen B or whatever, Proxima B, before we find it, in the seas of Europa.
Yeah, and then
I'll owe you a steak dinner.
Then everybody wins, right? Because on the one
hand,
you had to buy a dinner.
Matter if we find life outside of the Earth and we know that we didn't accidentally drop it there?
Yeah.
Are you really good at parsing? Like, oh, that one doesn't count.
Yeah, exactly.
It's around that exoplanet and not in the place that I wanted it to be. I'm not happy about this.
But we do agree that they come before some kind of techno signature.
I'm not saying that either. I can't say that if I want to keep my friendship with Jason.
Well, I don't know. I mean, I think that Jason probably also sees it as a bit of a long shot, but it's sort of like, why not?
It's possibly a long shot, but it's certainly still worth looking for, and it's a totally different avenue of investigation that's not dependent on the results of the other ones. I mean, you're looking at it in a completely different type of investigation. And if you put all of your efforts, in the biosignature direction and your remote observation of distant exoplanet, if you put all of your efforts in there and the signature comes from, the perpendicular axis of aliens, you're going to miss it. You gotta look in all directions.
Well, so we're just like a minute away from the end of our hour. I don't want to take up any more of your time, but I want to make sure that people can continue this journey to follow more of the work that you're doing. What are the best ways to follow what you're doing?
So you always should follow me on Twitter. Everyone who's watching right now should follow me. My Twitter handle is @astrokimcartier, and I always tweet about all the work that I'm doing, all the articles that I publish, and all the efforts that I'm involved in with science communication. So if you want to know what I'm doing in an up-to-date, in-the-moment type of way, follow me on Twitter. You can also follow my work on eos.org. That's eos.org, which is the Earth and Space Science magazine that I write for. Eventually, I will start updating my website again. So
Don't promise anything.
I can't promise
Yeah.
that. So stick with those 2 ways, and you'll always find out what I'm doing.
And of
Of
course,
course,
every
watch the
week.
Weekly Space Hangout every Wednesday night at 8 p.m. Eastern, which is 5 p.m.
Yeah.
For Fraser time.
Yeah, exactly.
Every Wednesday night.
Yeah. And cool. Well, so next week is going to be Morgan, which is the other co-host, and we'll be talking about planetary science. So I hope everyone will enjoy that as well.
Yeah. If you weren't satisfied with my answers about solar system science, ask them to Morgan next week.
Yeah.
If you want, tell them, this is what Kim said. We're gonna find life on Mars in 10 years, and then he'll shut me down. That's okay.
We'll find out which side of that bet he'll take. I'll make sure. Someone remind me to fire that past him and see what he thinks. Well, Kimberly, again, thank you so much for taking the time to chat today. It was a lot of fun. It was great to have the one-on-one conversation, because always it's such a madhouse with all of the stories.
Yeah,
that
there's
we're
always so
presenting,
much space news to talk about every single week. It's great to delve more in depth on all of this, and to give some of my own personal opinions on a lot of this science. It's great talking about my experiences both in and out of academia, and how to make that transition. And again, if anyone has any questions about that or concerns, please do reach out to me. I always love hearing from people and helping out where I can. So I was really glad we got to talk about that too.
To make that journey into science communication, you look like you're having just a really great time.
I'm having a blast.
Yeah,
it's been a great time, and I hope that I don't stop anytime soon.
All right. Well, thanks everybody. Thanks to the moderators. Thanks to all the viewers who are watching this week. Thanks to the people who provided a donation. That's amazing. And we'll see you. We've got an episode on Farewell to Opportunity that's going to come out in a couple of days. We've got a question show. Dr. Becky is going to be giving the guest answer this week. And then, of course, next week, and the Weekly Space Hangout on Wednesday. And, of course, we've got Morgan this time next week. So we'll see everyone later. Thanks, everyone.
Night.